All right, last video in this section is about degree and turning points. Um, a turning point on a graph is a place where the graph changes from increasing to decreasing or vice versa. So on a polynomial, it's always going to be a rounded hill or valley. So what I've got drawn here is a couple of examples. This is a turning point where it goes from increasing to decreasing, and this is a turning point where it goes from decreasing to increasing. And what I want to do is sort of develop some rules for this. The stuff I've got over here, we're going to work this stuff out. Don't worry about memorizing this stuff. It's just these are things that are sort of natural qualities of polynomials. The first one makes good sense. A line has no turning point. That's true because it's just straight. A quadratic function will have one turning point, and that's the vertex. So it'll either be there or there. Now, a cubic polynomial can have 0 or 2. And here's the thing to think about with a cubic polynomial. Cubic polynomials, they tend to look like this. Or they might look like this. Let me draw that one in. But, you know, if they rise on one side, then on the other side they drop. So like that, or like this. And so one of two things can happen. It can either look like this, where you have no turning point, or if you turn around one time, well, if it's a cubic polynomial, it's got to turn around again so that the end behavior can work out. So you can either have 0 or 2. And we could play around with Desmos if we wanted to. See, here's that's y equals x cubed. And if you start playing around with the other values, you can make it into something with 2 turning points, or you can still have 0. But there's no way to just get 1, because every time it hits a turning point, it turns around. So cubic polynomial, yeah, I said if it has 0 turning points and it has a flat spot. Let's go back and look at that. X cubed, if I do this, it has this one place. The technical word for that is a inflection point. So it never turns around, but it does have this inflection point here, which is kind of a flattened spot. Even if I sort of mess with it a little bit, there's still an inflection point in it somewhere up there, where it kind of flattens a little bit. Okay, degree 4 polynomials. If you think about a degree 4 polynomial, it has to have 1 or 3 turning points. Because a degree 4, if you have y equals x to the 4th, it looks kind of like this, sort of a flattened parabola. But if a degree 4 polynomial, one of two things happens with its end behavior. It's either down on both ends, or it's up on both ends. So if you it's possible to get 3 turning points. It's possible to get 1 turning point, but you can't get 2 turning points on a degree 4, because if you turn around exactly twice, you're going to wind up with your end behavior, one end going down, one going up, or the other way around. So if you work through this stuff, what you can come up with is a polynomial with degree n has at most how many turning points? Well, a quadratic has at most 1. Actually, it has exactly 1. Let's look at this. Degree, max number of turning points. Degree 1, that's a line, has 0 turning points. A parabola has exactly 1. Degree 3 we came up with a second ago said cubic polynomial has at most 2. 4th degree has at most 3. 5th degree, you work through it, it's going to have at most 4. So a polynomial with degree n in general has at most n minus 1 turning points. We'll change back to a darker color. A polynomial with even degree has an even number or an odd number of turning points? Well, you can just think about the most common polynomial with even degree, x squared. It has an odd number of turning points. Polynomial with odd degrees has an even number of turning points. Finding those turning points, though, can get complicated. And with the parabola, it's pretty easy to do because we've got a formula for the vertex of the parabola. But finding exact values of those turning points with polynomials of degree greater than 2, you need calculus for that. In general, you need calculus for that. There are some polynomials of large degree, like say x to the 6th. I mean, that has a turning point at 0. But just to find for a general polynomial of degree 6, you need calculus for it. All right, I think that'll do it for this section.